At the dawn of the 20th century, a revolutionary invention promised to change the world of rail transport forever. Its creator, Louis Brennan, a visionary engineer, unveiled something extraordinary to the world: the Brennan Monorail. This train was unlike any other. It walked boldly on a single track, defying the laws of physics with a grace that seemed supernatural. The magic behind the Brennan Monorail lay in an engineering principle as bold as it was simple: one track instead of two. Brennan was convinced that this innovation would not only speed up journey times, but also reduce railway construction costs by requiring only half the material traditionally used. 1910 was the year that saw the public presentation of this engineering marvel. The crowds were amazed to see the monorail not only maintain perfect balance on a single track, but also tilt nimbly through curves without any human intervention. This enigmatic behavior was made possible by a beating heart hidden inside the train, a gyroscope. To fully understand how this marvel works, one must immerse oneself in the principles of gyroscopes. These devices, thanks to their high-speed rotation, generate an angular momentum that keeps them stable. If you try to tilt a gyroscope, it responds with a precession movement, trying to regain its original balance. Louis Brennan, with an ingenious intuition, applied this principle to his monorail. Initially, he experimented with a small flywheel inside a model train, connecting it to an electric motor. As soon as the train threatened to tip over, the gyroscope disc went into precession, restoring balance. However, a challenge arose when the train had to negotiate curves. The gyroscope, trying to maintain its original position in space, would not rotate with the train, causing the train to tilt and potentially fall. The solution: Brennan installed a second gyroscope, rotating in the opposite direction and connected to the first by a gear. When the train curved, the unwanted precession was canceled, keeping the train stable and safe. Moving on to building a full-scale prototype, Brennan was faced with new challenges. The considerable weight of the train required more powerful gyroscopes to counteract the force of gravity. Brennan, with a flash of genius during a lunch, devised a new solution: actively controlling the precession of the gyroscopes. By connecting the gyroscopes to a petrol engine and placing them in vacuum-sealed containers to reduce friction, Brennan significantly increased the effectiveness of the system. Even in the event of a power failure, the gyroscopes would continue to run for up to 30 minutes, preventing the train from tipping over. To cope with vibrations and ensure a proportional and constant force, Brennan abandoned the guide plates in favor of an even more ingenious system. The gyroscopes were attached directly to the train frame, allowing natural and instantaneous precession. A mechanism of actuators and valves, controlled by the axis of the gyroscopes, regulated the flow of compressed air, forcing the gyroscopes to precess in the opposite direction until equilibrium was restored. This pneumatic system, acting with less force, generated more force, thanks to the magic of applied physics. Among the most fascinating aspects of the Brennan Monorail is its extraordinary application of the principles of gyroscopes, a technology that, although discovered centuries ago, continues to amaze with its innovative applications. The idea of using this technology to keep a train balanced on a single track sounds like something out of a science fiction novel. This detail not only underlines Brennan's boundless creativity, but also opens a window on how applied science can turn the boldest ideas into tangible realities. Imagine being a passenger on this train, barely feeling the tilt as the landscape slides past you, an experience that would offer a sense of flight rather than rail travel. The promise of faster travel and the thrill of defying gravity could have changed our approach to transport. The principle was simple but ingenious. Compressed air, pushed in one direction, exerted a pressure that was transformed into a force capable of moving the heavy gyroscopes in the opposite direction to the inclination of the train, rebalancing it automatically. The Brennan Monorail, with these technological advances, presented itself not only as a masterpiece of engineering, but as a true promise for the future of transport. The train's ability to remain perfectly balanced, even when faced with the challenge of having all the passengers on one side, was a testament to Brennan's ingenuity and perseverance. However, despite its technical success and public admiration, the fate of the Brennan Monorail was marked by financial and practical obstacles. At the time, the traditional two-track railway network was already well established, and the idea that each carriage should be equipped with its own gyroscope system seemed impractical in the eyes of investors. Thus, despite its revolutionary potential, the Brennan Monorail project failed to take off towards large-scale adoption. Reflecting on this incredible invention, we cannot help but admire the vision and innovation that drove Louis Brennan. His work reminds us that even if not all designs achieve commercial success, ingenuity and the ability to imagine the future are indispensable qualities that continue to inspire new generations of inventors and engineers. The Brennan Monorail, therefore, remains not only an outstanding example of engineering from the past, but also a symbol of the audacity to think differently, to challenge the status quo and to pursue bold visions. And even though today we travel on trains that run on two tracks, revolutionary ideas like Brennan's make us wonder what the next big leap in the world of transport will be. In conclusion, the story of the Brennan Monorail is a fascinating journey through human ingenuity, a reminder of our relentless pursuit of improvement and innovation. It teaches us that, even in the face of insurmountable challenges, determination and creativity can open up unexpected paths, charting the way for future inventions that may one day, in turn, change the world. Another aspect that deserves attention is the historical context in which the Brennan Monorail was conceived and built. The early 20th century was a time of extraordinary technological progress, with inventors around the world pushing the boundaries of what was possible further and further. Brennan fits into this landscape as a true pioneer, anticipating by decades concepts that we now take for granted in the field of transport engineering and design. This makes us reflect on how great ideas, regardless of their immediate success, can influence and inspire future technological progress. Brennan's legacy, therefore, lies not only in his monorail, but in the inspiration he continues to offer innovators who dream of building the future, a world where the limits are defined only by the scope of our imagination. Thank you, Louis Brennan, for leaving us this extraordinary legacy of inspiration. And with this incredible story of engineering, innovation, and time-defying dreams, we close our journey of discovery of the Brennan Monorail. This adventure into the past shows us that revolutionary ideas can shape the future in ways we sometimes cannot even imagine. Don't miss the opportunity to join our community of curious science and technology enthusiasts, ready to embark on new adventures of discovery. Subscribe to our channel, activate the notification bell, and become part of a community. Subscribe now, leave a like if you enjoyed the video, and share it with those who, like you, love discovering the secrets of engineering and science.